Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. This reaction involves the Prinz reaction, or a related acid-catalyzed addition of formaldehyde to an alkene. Under acidic aqueous conditions, H+, H2O, an alkene reacts with formaldehyde, HCHO, via a Prinz-type mechanism. Moving on to the next step. 1-methylcyclohex-1-Na is protonated by H+ to give the more stable tertiary carbocation at C1, the carbon bearing the methyl group, following Markovnikov's rule. Moving on to the next step. The tertiary carbocation at C1 attacks the formaldehyde, HCHO, acting as a nucleophile toward the carbonyl, or alternatively, the protonated formaldehyde, oxocarbenium ion, CH2 is equal to OH+, acts as the electrophile attacking the alkene. In the Prinz mechanism, protonated HCHO, CH2 is equal to OH+, is the electrophile. The alkene's pi electrons attack the electrophilic carbon of CH2 is equal to OH+, placing the positive charge on the more substituted carbon, C1 tertiary position, per Markovnikov selectivity. And for the final step, water attacks the tertiary carbocation at C1 giving an alcohol, OH, at C1. Simultaneously, the oxygen of the CH2OH group at C2 from formaldehyde addition is deprotonated. Weight re-examining, in the Prinz reaction with HCHO and H+, the alkene acts as nucleophile toward protonated formaldehyde. The more nucleophilic end of the double bond, C2 less substituted, attacks HCHO, placing the carbocation on C1 tertiary. Water then traps the C1 carbocation to give OH at C1. This results in C1 has methyl plus OH, and C2 has CH2O. This matches option B, the cyclohexane ring with methyl at C1, OH at C1 and CH2O at C2, drawn as 1-methyl-1-hydroxycyclohexane 2-methanol. Why other options fail? Option A, a simple diol at C1, C2 would require oxidation, not formaldehyde addition. Option C has CH2O at C1 and OH at C2, which would require opposite regiochemistry, carbocation at C2 less stable secondary, disfavored. Option D has two OH containing groups at C1 only, inconsistent with Prinz mechanism. Therefore, the correct answer is B. Therefore, the correct answer is option B.